Okay, so in this video I'm going to do a bit more sort of tricky question, and we'll just see how that goes. So find the area bounded by the curve f of x equals negative sine of x on 3 and the x-axis given that x is an element of 0 to 3 pi. Now the first thing I'm going to do in a question like this is I'm going to sketch it either using a calculator or just do it. This is a fairly straightforward equation, so hopefully it'll be a pretty quick sketch. And so that's just going to give us a bit more of an idea of what it is that we're actually dealing with, okay? And first thing I'm going to do is I'm going to calculate the period of this thing. So period of a trig function is 2 pi on n, which in this case is 1/3. And 2 pi divided by 1/3 is 6 pi. So I know that this function has a period of 6 pi. 3 pi is going to be exactly half of that. So that means I'm only going to see half of this sine function. Now it's a negative sine function, which means that from the origin it's going to go down first, and it's going to come back up, and then it would continue on for the other half of the function out there somewhere. But I can just sketch this pretty roughly. That's what I'm looking at. And so I'm trying to find this area in here. Now, I guess the first thing to notice is that's below the x-axis, so I'm going to need to do something to make it so that the area is positive in the end. But it's also nice that I've got my x-intercepts just at 0 and 3 pi, so those are the terminals of this graph. Okay, that's going to be the area enclosed in there, and it's between those 2 points. So I'm going to do the integral between 0 and 3 pi of negative sine x on 3. And make sure to write the dx on the end of it. I should probably also write, actually, that it's area, which is equal to that. So what I'm going to do next is I'm going to anti-differentiate this. So when we anti-differentiate sine, it becomes negative cos, but that's going to be countered by this negative sign just here, so it's actually just going to become cos. I also need to divide by the derivative of this, which is just 1/3. So if I have 1 divided by 1/3, that's actually just going to be 3. I'll also include my brackets here, so it's 3 cos of x on 3, and that's between 0 and 3 pi. The next thing is to sub in the terminals, so I've got 3 cos. If I sub 3 pi in here, I'm just going to get 3 pi on 3, which is just pi, minus 3 cos of, and subbing 0, and I'm going to get 0. And the next thing is that, 3 times cos of pi is just going to be negative 1, so it's 3 times negative 1, minus 3 times 1, cos of 0 is just 1, which gives the answer of negative 6. Now, remember how I said that we needed to do something about the fact that this area is below the x-axis, so basically we could just take the modulus of that or take the magnitude of it. An alternative would be to say that, well, we need to do the negative area of that and then just carry a negative sign right throughout all of the working. So I can just do this, which makes it negative 6, which actually ends up giving us the 6 square units that we're after as the exact answer. So it's pretty nice with these trig functions. Like, a lot of them actually have really good exact value answers, which tend to be integers and that sort of thing. It's, yeah, you can get some really awesome solutions from these kinds of problems. And yeah, that's just it. So a little bit of stuffing around, but I think it's nothing that's too bad, and you just need to remember to do the opposite of differentiating and make sure that you divide by that derivative of the inner function, because if you forget to do that, you can end up with all kinds of problems in your working out. Anyway, I'll leave it there. I don't think this exercise is going to require any more work, so timed it quite well, just 10 minutes worth of videos for that one. I'll see you in the next one.